Good morning, children. I welcome you all to this session of science. And in science, we are on to chemistry. We are studying structure of the atom. Right, children? You all know atom is the smallest unit of a chemical reaction, or maybe you can say of all the matter. Right, and all the matter comprises of this atom. Right. In this chapter, we'll be studying about in detail what is an atom. Okay, now the charged particle of matters was firstly there was the discovery of electron which was there, right? As you can see here, firstly it was electron which was discovered, and after that, and this the electric nature of matter has been indicated in very early experiments in the production of electricity, rubbing of glass ribbonite rod with silk of fur. Now in 1832, Michael Faraday showed electricity could be passed through solution of certain substances called electrolytes. Faraday observed that during electrolysis of an electrolyte, the charged particle migrate towards oppositely charged electrons. However, the discovery of electron came in the result of study of conduction of electricity through gases. At the end of 19th century, several scientists like Crookes, Julius Plucker, and J.J. Thomson. Now, this is the name which you need to remember, J.J. Thomson, right? Tried to pass electricity through the gases. They observed that electricity can be passed through gases only when high voltage is applied to them at a very low pressure, and this he did through an cathode ray discharge in a tube, right? Now, an English physicist, J.J. Thomson, studied electric discharge through a cathode ray tube at a very low pressure that was of 0.1 millimeter to 0.001 millimeter, when a high voltage of 10,000 to 30,000 volt was applied across electrodes. The cathode emitted a stream of invisible rays called cathode rays. Right? They travel in a straight line, and cast a shadow on any opaque body which was placed in their path. See here, there is an object. You can see here that this is an object, and then after that there is its image. Right? Cathode ray produce a glow fluorescence when they strike the glass wall of the discharge tube. Cathode ray gets deflected towards positively electrode when passed through an electric field. They are also deflected when they pass through a magnetic field. In this diagram, you can very aptly and clearly see that these cathode rays are deflected, right? You can see here towards the positive electric field, which clearly tells that these rays, they are negatively charged particles because opposite charges attract each other, right? Cathode rays possess kinetic energy and are comprised of material particles. When a small uh, pedal wheel is placed in the path, the wheel starts rotating. This mechanical motion of wheel is possibly only when cathode ray they possess kinetic energy, right? So that means cathode rays they possess ionization in gases. Cathode ray produce X-rays. When they cathode ray produce heating effect, and they can penetrate through the sheets of aluminium, right? On the basis of these cathode rays studied by J.J. Thomson and and other scientists, following facts were made known. The facts proved that electrons are fundamental constituents of all matter. Cathode rays are very small. Um, okay, they are very small negatively charged particle, and then Thomson gave a list of characteristics of electrons. He said electron is the fundamental particle which carries one unit negative charge and has a mass nearly equal to 1 by 1837 of that of hydrogen. The mass of it is almost negligible. The approximate radius is 2.780 into 10 to the power minus 15 meter. The charge is 1.6 into 10 power 19 coulombs. Charge mass ratio is 1.759 coulomb per gram, right? Okay, then in matter of electricity flow is due to electrons. Then proton was discovered, right? And then Goldstein conducted an experiment um, with canal rays or anode rays, and these rays are found to contain positive charge, as can be seen here. And so some characteristics were established for protons. They were generally it is represented by P, but in nuclear reaction as H. A proton has a positive charge 1.6 into 10 power minus 19 coulomb. Mass of proton is equal to mass of hydrogen atom. Charge to mass ratio for proton is 9.58 into 10 to the power 4. Radius of proton is approximately 10 to the power minus 12. Then neutron discovery occurred, and neutron was discovered by whom? Chadwick, right? A scientist called Chadwick, he discovered neutron, right? And, and then he devised certain characteristics for neutron. It said neutrons are electrically neutral particles. Generally, they are represented by n, and with in reaction 0n to the power 1. The mass was 1.6 into 10.75 into 10 power minus 24. Neutron had high penetrating power, radius 10 to the power minus 12 centimeter. Hence, neutron may be defined as fundamental particles which carries no charge but a mass nearly equal to that of proton, right? So, children, if you analyze this chart here, you will be getting all the desired data here in this chart regarding electron, proton, and neutron. Now, few early scientists gave some early models of atom. It was first was given by Thomson model, right? It was a plum pudding model, right? In this, he said that there was a sphere of positive charge inside which electrons were embedded into it. Then Rutherford came and he gave his own model, right? So Rutherford was a New Zealand-born physicist, right? He is famous for his work on radioactive discovery and nucleus of an atom. With the help of gold foil experiment, he also discovered alpha particle. He got Nobel Prize for that. But then came Niels Bohr. Niels had Henrik David Bohr was a Denmark physicist who made fundamental contributions to understand atomic structure and quantum, for which he received Nobel Prize in that. So he gave the following theories of spectra: atomic constitution, atomic theory, description of nature. Now he gave his model and said that atom consists of uniform sphere of radius 10 to the power minus 8 centimeter approximately. Positively charged protons are spread over the entire surface. Negatively charged electrons are embedded in this sphere in such a way that the net charge on the sphere is zero. Negatively charged electrons are embedded in this sphere in such a way that the net charge on the sphere is zero. Then this model failed to explain subsequent experiments done on atom, so it was soon rejected. Then Rutherford conducted an experiment of nuclear model, and this was his apparatus setup. The microscope lead box, there was an alpha decay through lead slid was also there, and then it was on a fluorescent zinc screen with gold foil, and the following observations were made. He said most of the part of atom is hollow. The positive charge is concentrated somewhere in the atom, and there is something very heavy in the atom. The returning back of some alpha particle indicates they have collided with something very heavy. So then, on the basis of this experiment, Rutherford gave his nuclear model. Rutherford said, proposed a model of atom on the basis of conclusion derived from alpha particle scattering experiment. He said almost all the mass and entire positive charge of an atom is concentrated into its center called nucleus. The size of nucleus is extremely small as compared to the size of atom, and there are empty spaces around the nucleus called extranuclear spaces. Now it had some drawbacks also. right? It had some drawbacks also, which says that Rutherford model was a very proved very fruitful, but soon it was pointed out that the concept of revolving electron was untenable from the electrodynamics point of view, right? Since electron is a charged body is moving around nucleus, it is accelerated, it will radiate energy continuously, as a result of which the orbit is bound to become smaller and smaller and until it drops. Now this problem was solved by Niels Bohr's atomic model, and later on Sommerfeld also introduced his atomic model. So Bohr said the electrons in an atom are revolving around a nucleus in certain selected but fixed concentric circular orbits, right? This is very important, that there is, he gave the concept of concentric circular orbit. As long as electron remains in a particular orbit, it neither emits nor absorbs energy. Energy is emitted or absorbed by an atom when it jumps from one level to the other. Only those energy levels are permitted in which angular momentum of the electron is an integral whole number multiple of h by 2 pi, where h is Planck's constant and its value is 6.63 into 10 to the power minus 34 joules per second. Then going by composition of nucleus is the center part of atom. It consists of proton and neutron. The positive charge on nucleus is held due to the presence of proton inside it, right? Then he gave this concept of energy levels or energy shells, right, and gave it numbering as 1 2 3 4, and then designated them later as K, L, M, N, O, P, Q, right? You need to study this diagram. Now principal quantum number n is equal to 1 first shell, K is 2 second shell, L 3 third shell, M, and fourth shell is N. The energy associated with certain energy level indicates with the increase of its distance from the nucleus, right? Now for the distribution of these electrons, he gave a formula 2n square, where n is the number of that energy level, right? Right, for first n was 1, so he put it and found out that in the first in the first orbit, number of electrons will be 2. Similarly, in this, for the second one, 2 into 2 square is equal to 8, and so on and so forth. And on the basis of that, he gave a electronic configuration theory, and this was how this chart tells how does he configured the entire thing, right? All elements from 1 to 18, right? So I stop here, and I hope you enjoyed it as much as I did in making it, and until we meet again, it's a goodbye.